Right, we're going to be doing this problem here, and in order for you to be able to actually have something to look back on later, something in your notes that's useful, I would say write down this problem, especially the table, and then what I'd like you to do is individually find the slope of the secant line between t equals 40 and each of those four other t values. As you look at this data, one question that sometimes comes up is, yeah, but what's the equation? We don't know the equation. But we have all of the data in the table, so we don't need the equation. All right, so let's take a look at part A, the work that's involved with that, just to make sure you're on the right track here. So for part A, I'm dealing with t equals 36. So as I take a look up at my table then, I know I'm dealing with this piece of data right here where t equals 36, and so I'm also going to be dealing with its heartbeat value as well. The other one I'm dealing with is because all of these are working with t equals 40, I'm also going to be working with this one and its related heartbeat value. So for part A at least, those are the two I'm worried about using. So I need to find the slope between those 2 points. Slope is delta y over delta x. So the change in y over the change in x. The change in y is found by subtracting our two y values. So I'm going to go 2530 minus 2806. Those are my two y values. And then I'm going to do that over 36 minus 40. So on the top we get negative 276, and on the bottom we get a negative 4. Now we can go ahead and do that division. What is negative 276 divided by negative 4? And so when we do that division, that gives us a positive 69, because notice a negative divided by a negative is a positive. Side question here. Some of you wouldn't have written it like this if you did the subtraction even. Some of you actually will have written the 2806 first. Is that okay? Yes, if. If I write the 2806 first, what else needs to happen? The 40 also has to go first, yes. The order doesn't matter so much as long as our order is consistent. We just need to go both of these numbers first or both of these numbers first. It doesn't matter which as long as you're consistent between them both. Repeat that same process to complete the answers for B, C, and D, because that is our final answer for A. And as you're doing those other ones, notice you're still using the point at 40 and 2806. It's just a matter of which other point you're using along with it. And then once you've gotten them all, it's time to check and see how well you've done. Here are our answers for B, C, and D. Check each of those. You'll notice they are all fairly similar to each other. None of them are way out there, which would have told us, hey, we better check this one number because it's probably a mistake somewhere. And then all of these represent secant lines. Well, every time we've been finding these secant lines, we've always been using it with a different target in mind. We're always heading towards the idea of trying to figure out what the slope of the tangent line is. So we're basing all of these calculations around t equals 40. So as we take a look at this, we now want to estimate what the slope of the tangent line probably would be. So in doing so, I want to find 2 points, kind of find out which ones between those. Which of these answers are the most useful to us? Which two? A, B, C, or D? Yes, B and C would be the most useful because they are the two that are closest to 40 over here. And so if I want to estimate the tangent, what will I do? All right, and so in order to come up with our tangent estimate, I would take the average of those two numbers, so 72.5 and 71, add them together, divide by 2, looks like we're going to get an answer of about 71.75, somewhere in there. Now, is that definitely the exact slope of the tangent line? No. There's nothing magical about being halfway between two other slopes here. However, it does give us a nice idea of about where it might be. But we might be able to get even closer to it. How could we get an even better estimate than that for our tangent line? Yeah, to get a better estimate, it seems like we would really need more data. We would need to know, for instance, at t is 39 and at 41. Or even better, how about like 39.9 and 40.1, that sort of thing. But we don't have that data. If we did, then we could actually use it to get a better and better estimate of what's happening exactly at 40. But without it, we just get as close as we can with the data that we do have. In the last problem, I gave you the table of values, and I gave you that data. In this problem, I'm giving you the equation again. We're going to be dealing with the equation cosine of pi x. And we are going to find the slope of the secant line through P and Q for all of those different x values. So just to make sure that we're starting off on the right foot here, like if I was doing the x is 0, if x is 0, what is y? Well, we'd actually have to calculate that, right? You'd have to go y equals cosine of pi times 0. Well, pi times 0, of course, is 0, so that's going to be cosine of 0. What is cosine of 0? And so y ends up equaling 1 there. And so then when you go and do this first problem for x is 0, you are finding the slope between 0.50 and the point 0, 1. Now, a little side note here. When we did this calculation to get y equals 1, did it matter whether we were in degrees or radians? No, because it was 0. But it will matter for the rest. Should you be in degrees or radians? Well, the pi here would possibly suggest to you which way it should go. It is radians. So make sure your calculator is in radian mode as you go forward. And so I'm finding the slope now between these 2 points. So I do delta y, so 0 minus 1, over delta x. That's going to be 0.5 minus 0. Remember, go in the same direction for both. That gives me negative 1 over 0.5, which gives me negative 2. So my first slope in my table here should be negative 2. Repeat the process for the others. The numbers are just going to get uglier as we go. All right, and now checking in on the x equals 0.4 for one more data point to make sure everything is going well. We plug 0.4 in for x, so we're doing pi times the 0.4 there, and then do cosine of that. That gives us a big long decimal, about 0.309. Now, you notice when I wrote it up here, I put these dots after. That's just to remind me and remind you that this decimal goes on and on and on. So I'm going to want to use the whole decimal when I do the calculations. I'm just writing down a rounded version to keep track of which number it is. So now I need to find the slope between 2 points. Again, it is between 0.50, because it's all between that point and the point that we're finding here, which is at 0.4, 0.309, and on and on and on. And so we're going to go delta y, 0 minus 0.309, and on and on and on, over 0.5 minus 0.4. And then do that calculation, and we get an answer that is about, get some more room here, 3.0901 6, 9, 9. It keeps on going and going and going. We need to be correct to 6 decimal places based on the instructions here, so I'm going to go 0170. All right, so now it is time to check each of those values that you would have come up with here. And for any of them you didn't get or didn't get correct, write down what the correct answer should look like here, because we're about to use it to estimate the tangent. Because remember, that's the big reason why we are finding these secant lines. We want the slopes of the secant lines because they let us approximate the slope of the tangent line. All right, so as you're taking a look at these values over here for our slopes, we're really interested in the slopes that are getting closest to the original x value, this 0.5 x value. So these certainly should be the closest over here, and so these should be the closest slopes. And notice that those two slopes out to 6 decimals are in fact the same. Now if you keep going into more and more decimals, you will start seeing the difference between them, because of course they are approximations. So that number there, negative 3.141587, it looks like it's about the slope of our tangent line. What's maybe a shorter way to write this apparent slope? How about pi? Because yeah, doesn't this look like this is just the value of pi? Which would kind of make sense considering that our original equation up here actually had a pi in it. So it's not totally out of left field. So we can go ahead and estimate the slope of the tangent line to be about pi. All right, now to bring this idea home about what it is that we're really finding here, we're trying to figure out the slope of the tangent line, and graphically speaking, that would be the tangent line that's right about here. So if I was drawing the tangent to the curve there, right at this point, that's about what we have found. It's the slope of that line. We found that is about negative pi. And when we talk tangent, that's what we're talking about. The secants that we were finding, all those secant lines that we were looking at, all of those were slopes between that point and, for instance, that point. Or a point over here, which are all pretty close to that tangent line, but none of them are exact. None of them are exactly where it is. So that's why we have to get closer and closer in order to see more and more accurately what that's going to be. And so now that we know that our slope is about pi here, I would like you to please now write the equation of the tangent line to the curve. And yes, you're doing it with a slope of pi, so go ahead and leave it in terms of pi. You shouldn't have to go into a whole bunch of messy decimals. And yes, thank you for the clarification. I keep misspeaking. The slope is not pi, the slope is negative pi. I just keep forgetting to say the negative. So to find the equation of the tangent line here, it's going to be y equals negative pi x, because negative pi is my slope, plus b. And I got to figure out what b is in order to be able to complete the whole thing. So I plug in my value of x and y that I know, so the y value is 0, equals negative pi times 0.5, that's my x, plus the b still. And so I can add that pi times 0.5 to both sides. So negative pi, wait, no, I added it, sorry, pi times 0.5 equals b. And so if I wanted to, I could actually leave it in those terms. I could leave it as b equals pi times 0.5 and write that into my equation. Y equals negative pi x plus pi times 0.5. But pi times 0.5 just looks a little bit more awkward than it needs to. So 0.5 is the same as what fraction? 1/2. And pi times a half equals what? What is half of pi? Pi over 2, yeah. So I want to write it as pi over 2 just because it's that little bit cleaner to write it that way. So then my final equation is y equals a negative pi x plus pi over 2. It seems weird when we do this problem because pi normally is focused just on sine and cosine and circles and all that. Lines normally don't involve pi in any way, yet this one does. But the process, notice, was the same as what you've used when we've had decimals or whole numbers in there in terms of how do we figure out what the y-intercept is and finish out the problem.